Hey, we think we're making a video.
What's up, everybody? It's time to learn about some momentum.
Now remember,
Momentum.
there's a mom in momentum, okay?
There's also a tum.
A tum. There is a tum in momentum, okay? Uh, Now I've patented this phrase, so if you're going to use this phrase, you've got to do like, one of those things like that, okay? Momentum is the keep goingness of an object.
How badly does it want to keep going? I mean, something's moving and it really wants to keep moving, right? So how bad does it want to keep moving? Well, that's going to be its momentum.
That's how bad right there, right? So if you just, it's as simple as multiplying the mass by the velocity, okay? Isn't that simple?
Real easy. So if you got a mass that's in kilograms and a velocity that's in meters per second, gee, boys and girls, what do you think the units of the answer are going to be? Would it be kilograms times meters over seconds?
Well, I don't know. Let's see. Okay, so let's suppose you've got 5 kilograms going 2 meters per second. Well, that's going to be 10 kilogram meters per second. And there's no other unit for that. There's no short version of it.
No special thing like a Newton or a joule. It's just kilograms times meters over seconds, and that's the way it is. But don't fall for the trick of where they put the mass in grams. Pff,
Yeah,
come on.
It's got to be kilograms.
You got to divide it by 1,000 to go kilograms. So that's the main trick that they do.
That's the only thing.
All right, let's rock and roll. What's next?
Oh, and then, so here's the deal, right? We're going to do this. I'm going to take an air track, and I'm going to send a little bitty glider, and it's going to go fast. And you know that if that hits a big glider, right, the big glider can be going slower than this guy. And when they collide, okay, it's possible for them to stop dead. And if you wanted to know how fast this guy needs to go and how fast this guy needs to go, you just calculate their momentum, right? You go m times v of this guy, m times v of this guy. If this is equal to this, they'd be opposite each other, right? Then it's going to stop.
They'll crash. Just kind of like, you got to think like the little guy would be like Michael James. And the big guy would be like a big, ugly lineman from, say, Ohio State.
Right.
And, of course,
Ugly.
Michael James, he won't run into him because he's just going to go by him. But if he did run into him, then they would stop dead.
Yeah.
Big, ugly guy.
Right. So the fast football player hits the slow big guy, they could stop, right? I think, what does it do? They can stop dead. They don't die, really. And then this is like, big mass, little velocity, little mass, big velocity. It's possible, right?
The Michael's quick. Pew!
All right, so this is like as hard as it gets, okay? 40 meters per second, by the way, is about 90 miles per hour. So this is a fast pitch, right? So 145 grams. What can we just use that, Mr. Duggan?
No, don't fall for that, man. Come on now. It's like, please. How dare they challenge me with their somewhat primitive skills? You got to switch that to kilograms.
Divide by 1,000. Right, so there's 0.145 kilograms times 40.
And so if we do that math, 0.145
That's
times
Mr. Duggan
40,
doing the math, by the way.
that's going to be 5.8.
And that's meters per second. And
I was up in the calculator. I didn't see that the answer is up in the left-hand corner.
yeah, I did that just so that I know whether I needed to stop the video. And
But wait.
Times kilograms.
Kilograms.
Yeah, kilogram meters. Meter, kilogram. It doesn't matter.
Yeah.
That's a weird way to write it, though. Why'd you write it that way, Mr. Duggan?
I don't know.
Okay, so this is my mom, right?
Yep.
And,
60
she
kilogram
runs-
Fran. That's what they call her.
That's what they call
She's
her, and
awfully nice.
She runs this way into Joe. Oops, Joe's got like a big butt. Oh, sorry. Okay. And they run into each other, right? And so in order to stop dead, what's got to be true about the momentum?
It's got to be 0. So if they're going to run into each other in a loving embrace,
Yeah.
just like in the movies, right? And like picture a field and like, oh, Fran, oh, Joe. And so let's see what happens. Fran's got a momentum of 240, right? And you got Joe, he's got a mass of 80 kilograms. Now, tell you what, it's the question of the day, boys and girls. What could this velocity be? It's got to be something.
It's got to be something so that they have the same momentum, right?
So it's 240.
So-
Let's see, 240 And 80 times V,
I think it's 3.
I think it's 3 too.
Yeah, there you go.
For a second, I was going to be all like bad
Yeah.
math and say like it's going to be
Something
like
else.
160.
But it's not, it's 3. Yeah.
But that would be stupid. It's 3.
So the deal with this, and the reason Mr. Duggan said that it's 0 is that if this is a positive velocity, right, isn't Joe's velocity negative,
Gotta be.
right? And so actually the momentum before was positive 240 plus really this is negative 240, right?
Hey, math geniuses. If you have positive 240 and negative 240, what does that add up to?
Yeah, before the collision, their momentum was 0. Their total momentum was 0. This is called foreshadowing. We're not going to learn this today, but this is always true. If you add up the momentum before a collision, it always equals the momentum after the collision. And of course, we knew that they were going to stop dead, so we rigged it so that it was 0, yeah?
Exactly.
Yay.
And that's it. And
Stay tuned.
stay tuned.
Try some of these.
Physics time, same physics channel.